Let's talk about the equilibrium expression used for balanced chemical reactions in chemistry. Let's just get some facts out of the way, some big things right there. It is symbolized with a capital K. And I emphasize capital because there's a lowercase k constant. This is a capital K. And very simply, although not complete, it is the products over the reactants. I want to hammer that in first before we talk about details, because that detail, that it's products divided by reactants, I want you to make sure you get that order correct right there. Four things about this equilibrium expression. You calculate capital K, and it is a number that is unitless. Okay, it is decided that this number will not have any units, because as you will see, as you calculate using different balanced chemical reactions, it could have many different units, which is not helpful as a constant. So we decided that it's unitless. You need a balanced reaction to begin with this. You cannot write a complete equilibrium expression without a balanced reaction. You can't do it with a reaction. You need a balanced reaction. 3, it refers to the terms of molarity, which is capital M. Now the unit symbol for molarity is capital M. And in the capital K expression, square brackets are meant to signify molarity. So in this chapter and beyond, if you see square brackets around a chemical formula, it is hieroglyphics telling you that it is molarity, moles over liters. And the fourth thing about this is that it is only multiplication and division. It is multiplication and division. Fourth thing about the equilibrium expression. So I'm going to write down now a balanced chemical reaction and show you how to write the capital K equilibrium expression for it. I'm going to do the combustion of methane. So methane is CH4 and it is a combustion reaction. So it has oxygen as its other reactant, H2O, and CO2 as its two products here. Now I said that we have to write a balanced chemical reaction here. So I have to balance this sucker out here. I'm going to take a leap here and think. Let's see here, that gives me I think it's that simple. But let me check with my ledger. Yes, it is that simple. The products divided by the reactants. This term here, H2O, we need the molarity of H2O, and that's what those square brackets mean. This coefficient from the balanced chemical reaction becomes a superscript, so a squared term. So whatever this molarity is will be squared. CO2, the molarity of CO2. The reactants go on the bottom. So the molarity of CH4 the molarity of O2 squared. The capital K expression has four qualities. We didn't calculate it, but when we calculate a number, it will be unitless. We need a balanced chemical reaction to write the capital K expression. The coefficients become superscripts. So in this case, they become squared. You could imagine things also become cubed and so forth like that. Okay, if you have threes, I don't know what you call fours. Okay, molarity. Okay, the concentrations that these square brackets are referring to is molarity. That's a hieroglyphic. And lastly, it's just multiplication and division. These terms are squared and then multiplied, squared, multiplied, and division. Thank you.